Alright guys, welcome to the session for today. So is everyone in the meeting? Alright, so what we are going to do is, okay, yeah, I can see everyone. You are all there in the meeting. So shall we start? So the other thing that we need to, you invite your friends, right? It's a free learning session, so you should be inviting your friends. Alright. Okay, so let's get started. So for irrational, uh irrational is just a number. Let me give you root 7 like that. All right, so this number, what will be happening is that once you punch on your calculator, it will be giving untraceable numbers. Let's say it give you 2.63463592. It continues like that on your calculator. You can't trace the pattern, but for rational that's a different case. So those are the numbers we call irrational. All right, so there will be those, they are not terminating, but they end at some, they don't give a traceable pattern. So there are only things under this. We matter what is important, so we be mattering what is important. So what is important matters. All right, so there are only two situations, A and B, of which rational numbers will be asked, and your duty is just to master scenario 1 and scenario 2. All right, let's get scenario 1. So suppose you are asked to say prove that root 2 is what is irrational. All right, so we are asked this question. This is question 1 type, so it can be root 7, root 5, everything like that, root 3, everything. So you write what I want to give you. All right, so how do we achieve this? You always start to say we prove, or proving by contradiction, proof by contradiction, or proving by contradiction. So this is the first statement you should be making. All right, so this is the first statement you should be making once you are solving this. So we say proving by contradiction. All right, there is contradiction like that. Okay, so prove by contradiction. So how do we achieve? We always prove by contradiction. So you always even underline this statement. All right, you underline the statement. Then from there, what next? What you do is, suppose you tell them now to say, suppose, so you say suppose the same root 2, okay, was to be rational or is rational. All right, so for your own information, rational numbers we know are numbers that are in the form of a over b. All right, where b is not equal to 0 and a and b, these are just numbers, integers. All right, so suppose root 2 is rational, comma, it can be expressed in the form of then. Okay, then it can be expressed in the form of a, over b, like that, where b is what is not equal to 0 and a and b are just integers, they are just numbers. All right, so and a and b are just integers and they do not have a common factor, so do not have a common factor. So these two in their ratio form, they do not have a common factor. All right, so this is where now my answer will be, my conclusion will be based on. So they would do not they won't have a common factor except maybe one. Let's say it's 1 or 3 over, I mean 2 over 3. These they only have a factor of 1. All right, so such an example is a over b. All right, and that's rational. So now what you are going to do is we write, all right, we write the same root 2. We say now it can be equal, it can be expressed in the form of a over b. So we have equated to the form of a over b, where b is not equal to 0. All right, so what we do, we cancel the root by what? By squaring both sides. So this will be 2 is equal to a squared, by the way this is squared there, all right, then over b squared, like that. So what do? You cross multiply there, then it will give you a squared is equals to 2b squared. All right, from here what we do is you give now an statement. So this is the equation 1 to 7. So you give another statement. You say we see that you know, we are now seeing that we see that a squared is what? Is an even, because it's squared like that. A number that is squared is always an even number. All right, hence it is perfect. It is perfect, right? So meaning that its square root is also an even. All right, it's perfect, meaning that its square root, its root is also an even. So a number that is squared is an even. All right, it's more like I tell you to say 2 times 2 is giving me 4, right? So this 4 that I have, let's say it's 2 to the power 2. All right, so this number, it can be divided by 2, and that's an even to give what? 2. So this number, the same 2 to the power 2, that is a perfect number, meaning that, I mean that is a squared number, meaning that its root also is an even. So the 2 is 2 times 2. All right, so this is an even. You can divide by 2 like that. So those numbers will be divided by 2. That's a meaning there. So from here, what do we do next? So you say this is equation 1. You give now another statement. We see that a squared is what? Is an even, is even number. All right, is even number. All right, hence it is what? It is perfect. For us to see that it's an even number, you say it's perfect. All right, it's a perfect square, by the way. So since it is perfect square, all right, meaning that its square root now, its square root is also what? Is also an what? An even, like that, or just is even. All right, sure. So once you are done this, there exists a factor now a. You bring the same a, you say there exists a factor, an integer k. You get the point? So you bring this, you write this what I've just written. All right, so you write what I've just written, you give them this statement to say there exists what? There exists a. So let me write there exists. So there exists a, all right, is equal to, we are trying to what? To find the square roots. So there exists a, all right, to k, like that. All right, so from here, based from here, so you always give this statement. If it was a number, you put a is equals to that number which you have here. All right, so you write this statement to say a is equal to 2k. This is just a factor from our square root assumption. So you always write this kind of thing, so don't forget that. Okay, so where this k is just an integer, you know, a number on a number line. All right, so from there now we can say this is now our equation 2. We can now conclude to say we have a is equal to 2k, like that, right? After having this, we'll name this as the equation 2. Right, So we can go now to equation 3 and say we are going to substitute now equation 1 2 into equation 1 there. All right, we are going to substitute into that. So how do we achieve this? We are going to say 2k, all right, is equal to a. All right, or let me just start from the other side. We know that now our a is equal to what? 2k. All right, so we substitute, and equation 1 had what? Equation 1 had a squared is equal to 2b squared. So we substitute this a that we have there. So we are going to have once we substitute where there's a, so a is giving us to say is this one. So wherever there's a, we'll put that 2k. So say 2k, all right, squared like that is equals to 2b squared like that. You get the point? So from there now we square. So this will give us what? This will give us 4k, all right. 4k squared is equal to, you square everything inside there, then you distribute in short the power, then that will be 2b squared. All right, so from there you can divide throughout a common factor of 2, so you divide through that. All right, so this will give you b squared is equal to 2k squared like that. You get now? So it will give you that, so that will call it equation 3. All right, so so we leave this space, leave that space. We are now concluding. Leave that space. So I'm going to lab, make sure that you have copied somewhere. All right, so all these I'll lab them. We are here. All right, okay. So all these statements should be in your mind. You always bring them on board. This mathematics about statements. All right, if you don't expect just solving. Some lecturers will not accept that. So the standard way is by what? So we continue from here. All right, so what we do is now you say again another case has happened. We have now b squared is equal to 2k. All right, squared like that. Okay, so what we do is now again equation 3, this is our equation 3. All right, so you give another point to say now that equation 3, all right, shows that b squared, same thing is now appearing, is an even. B squared is even. All right, so since it's an even, meaning that its square root b is also an even, meaning that its meaning that it's what? Its square root is also what? An even, or is also even. All right, so you write this statement, it's also even. After writing is also an even. All right, so we have now seen that now that equation 3 is also applying to equation 1 at this point. All right, so meaning that we are now concluding. All right, meaning that a and b have a common factor, because we saw that 2 was a common, could be divided throughout. You get the point? So we conclude now by saying a and b, a comma b, have a common factor. All right, have a common factor what? Of 2. All right, so since they have the common factor of 2, this contradict our earlier assumption that they do not have what? A common factor. So this is contradiction to our assumption that, okay, it contradicts our earlier assumption that they have no common factor. All right, they have no common factor. All right. So this contradicts our assumption. At first, we gave our assumption to say they do not have a common factor, and we have proved these stages. And it was giving us what? It was giving us the same things. I mean, it was bringing out the common factor, of which we didn't specify in the first statements. All right. So that's about with case 1. No, we have remained with case 2, which is just the very simple one. So make sure that you just master the sort of English which is there. Okay, master the type of English which is there, then we'll be ready to go. Okay, so in this one I'll be very fast. So you can also try this one. So try and inbox. So try root 5 comma try root 3 and also try root 7, like that. Okay, so prove that. All right, and inbox on the line 09700200920, like that, on app. All right, so another case now, case B. We have done case A, now case B. All right, so how do we start with case B? So let's say we are told to say they give you a statement. They will be always giving you a statement, by the way. All right, so they'll be giving a statement always. Okay, so they'll give to say a condition to say if root, let's say, let me just give whatever. Okay, root 3 is what? Is irrational. All right, like that. Is irrational number, like that. All right, comma, then they tell you to say show that 2, let's say, plus the same thing they have mentioned, root 3 is what? Is not relational or is relational. All right, so what we do is you start also again, you write the same statement to say we prove by contradiction. All right, proof by contradiction. So you give the statement to say proof by what? Contradiction. So that's the statement you give. Okay, so now after you underline as your title, we assume that, all right, we are going to assume that what they have given us is relational. We are going to assume, or let me just say assume, because I'll finish just my all right, you just have to understand. So assume the same 2 plus root 3 is what? Is rational. All right, so rational is always our reference. So assume 2 plus root 3 is rational, meaning that then, all right, I'll say then the same thing we have, then the same root plus root 3, I mean 2 plus root 3 will be equal to a over b, and we saw this to say where b is not equal to 0. All right, from here then you can group the like terms. So remain with root 2, all right, is equal to a over b, then minus 2, like that. Okay, so from here then what we do is, by the way, that was root 3 inside the brackets there. So from here what we do is now we can group these terms which are on our right side. All right, so this is b, all right, b into that, that's a, all right, minus b into that, that's 2b. all right, so from here then what do we do now? Okay, so we are done now. You end here, there's nothing we can do. So the last statement suggests that it's relational. So these a comma b, they are just integers, meaning this number, even if we substitute other values, it still give what, a over b, or a number, let's say 2 over 9, like that, which is relational. You get the point? So it always producing that. So that's the meaning when you reach at this point. Now we conclude with a statement. Forget about this. So you conclude with a statement to say the last statement, this one we said is the addition. So the last statement suggests that root 2 is relational. So here, if this one is irrational, that's what they said, right? So if root 3 is irrational, so we are saying now this is irrational, and this what we have this side is what is irrational, because they are in the form of a over b, like that. Okay, so the last statement, or the first statement, suggests that the first statement suggested, all right, suggested, it suggested that root 3 is what, is relational. All right, is irrational. So since it is irrational like that, all right, and where these ones are just integers, this a over b is an integer, also we can just say a minus 2b there, it is just an integer. These are just integers. All right, then this contradict. So once they are integers a and b, meaning that they will produce a rational number in the case where they, or in the form where they are, in the relation where they have been placed. So this contradict, this is a contradiction. All right, so let me say this is a contradiction. Okay, so this is a contradiction. Irrational can't be equal to rational. All right, so this contradicts our assumption. It can be rational. So you can't have a situation whereby let's say n number is equals to a b over, let's say, c, and the c is not equal to 0. So we can't have irrational being equal to something. It's more like we are saying a girl is equal to a boy. That is wrong. So what we do is now, those are just the case that you need to prove, guys. All right, so that is it about rational numbers. All right, so the next topic you do okay, we'll see what we can do. Otherwise, thank you very much for watching the video. Please share, subscribe, like our videos so that we can give you more of these. Thank you very much.